We live maybe the richest country in history, and yet still almost everybody I know is basically a slave. Almost everybody is working all the time just to get the necessities to survive. Right now, it's because of gross inefficiencies in the system, especially our transportation system. Housing is insane. It's becoming more and more difficult to afford anything. And you've got politicians claiming that they've got solutions, whether it's universal basic income or socialism or fascism. But all of those are terrible ideas, let's be real, and also probably none of them are actually going to work, especially when most industries are now completely overrun by giant multinational corporations that have squeezed every last penny of profit out and made it almost impossible to make a decent living in the middle class. And I have a solution for all of that. It's a technological solution, and it's called airships.
In 2013, I launched an Indiegogo to build an airship. I was hoping to pursue airship design in a manner similar to the way Elon Musk has been developing Tesla. Make a few ridiculously luxurious flying RVs so movie stars and other celebrities could take the comforts of home with themselves anywhere in the world, and then once the company was in profit, work on a smaller commuter vehicle reasonably priced for the general populace. My Indiegogo was not a success. I had a few backers support me, but all at one of the lowest levels, which the reward for was a collection I had amassed of every documentary I could find about airships. Sadly, most of my backers were international, and between purchasing USB drives and international shipping costs, I pretty much broke even. And that's only if you factor in my labor cost as basically free. Popular Science wrote an article about it, and I was super excited. I've been a Popular Science fan since I was a kid and used to ditch social studies to read it in the library. But if you read the article, they basically roasted me pretty hard. And honestly, I can't totally blame them. The concept was sound, it still is, but I didn't really tell enough of a story, and I certainly didn't give many details of my design ideas or concepts. But all success comes from the ashes of failure, so let's try again. In the 1930s, we had giant luxury floating hotels that could take passengers across the Pacific in extreme comfort from Germany to Brazil for tropical vacations. But there are a number of huge problems with that era. For one, rather than repeatedly testing small iterative designs, the Zeppelin Corporation was hyper-focused on building ever more gigantic airships, usually at exorbitant cost, and making some design decisions that were frankly insane. Secondly, the airship industry at the time was almost completely being developed in Nazi Germany. They were not popular internationally, and had a hard time getting a lot of the materials they needed. Plus, they had just got their butts kicked pretty severely in World War I, and also, this was primarily during the Great Depression, so needless to say, funds were pretty tight. Thirdly, the leader of the Zeppelin Corporation, Hugo Eckener, was not a Nazi fan, so they basically kicked him out of the company and had pretty poor leadership by the late 30s. As a result, they had to cut a lot of corners and use less than ideal materials in the construction of their airships, eventually leading to the biggest flying vehicle ever made, the Hindenburg. Now, the Hindenburg was an absolutely preposterous design from the word go. It was enormous. It was over 800 feet long, and it was meant to carry 5 million cubic feet of hydrogen. It had been damaged by a high-ranking Nazi official who had smashed the tail section into the ground while trying to impress his girlfriend. It had been designed to use helium, which the Nazis couldn't get because the only place to get helium was in the US, and tension was already pretty high during the Hindenburg's construction. Then when funds ran low during the construction, this was the Depression after all, they made a few substitutions in the recipe for the exterior paint. The result being that the entire thing was basically painted in a mixture of thermite, gunpowder, and the solvent they used to mix those together was not much different than rocket fuel. Thermite burns at 2400 degrees Celsius. That's hotter than the core of the sun. I wouldn't ride a bicycle painted with that. Now think about the era that airships were initially developed in. It was predominantly World War I and II. Airships are not really a good design for war. They are giant bags of gas, not well suited to withstanding bullets, rockets, or any other violence. By design necessity, they have to be very lightweight, which means they really can't take a beating. Now, Germany still used airships extensively in World War I to drop bombs indiscriminately across the English countryside and cities, and also for reconnaissance. The Americans even built an aircraft carrier called the USS Macon. You should really check that out if you haven't heard of it. It's fascinating. Anyway, the point is, airships are not well suited to combat or war. and yet almost all of their development and testing was done in and around World War I and II. Also, the late 20s, when airship development really peaked and ended, was a long time ago. It's 2019. That was almost 100 years ago. They didn't have a working altimeter back then. It was invented in World War II. Most airships used a barometer to gauge their elevation, and when the weather changed, if visibility was bad, sometimes they would fly right into the ocean and immediately disappear beneath the waves, because remember, they really can't take a beating. They didn't have carbon fiber. They didn't really even have plastic. Most of the air cells were made out of cow intestines, by hand. The frames were aluminum, or an aluminum-based alloy, which is actually pretty heavy and also an electrical conductor. Not a great material for designing rigid airframes, especially ones filled with explosive hydrogen gas and painted in thermite, gunpowder, and rocket fuel. They didn't have computer modeling. They didn't have computers. They didn't have the internet. They didn't have radar. They didn't have LiDAR. They didn't even have color cameras. They didn't have graphene, carbon fiber, or 3D printing. They didn't have aerogel. They didn't have lithium-ion batteries. They didn't have computer-aided design. A lot of the world was still riding horses, and in some countries, radio and record players were still rare. Needless to say, we could make much better and safer airships in 2019 than would have been possible in 1931, the year the Hindenburg was starting to be built.
So there were some very successful airships back in the 1920s and 1930s. The Graf Zeppelin, I think, is probably the best example. It flew almost 1 million miles with virtually no injuries to any of the crew or passengers. The airships and Zeppelins of the 20s and 30s weren't that successful, mainly due to design choices that were made. A lot of the designs were based on older naval designs, and naval vessels are completely different than vessels designed for navigating the air, for a lot of reasons. Obviously, floating on the ocean is going to be quite a bit different than floating in the air. Naval ships can have a very high vertical profile, and it doesn't really affect their navigation. They're not as affected by crosswinds and sidewinds, and in fact, in the case of sailboats, having a high vertical profile is actually an advantage. A lot of the airships, especially the American models, needed to be reinforced because of their high vertical profiles and their inability to navigate storms and crosswinds and any kind of air turbulence that was going to affect their structural integrity. A couple of American airships specifically were lost that way. So my design is going to be quite different than the old designs. They were longer, cigar-shaped designs that were really meant to travel in one direction in a way similar to a naval vessel. My design is going to be disc-shaped and much shorter on the vertical cross-section and much wider on the horizontal cross-section. There's a number of reasons for that, but basically it has to do with aerodynamics, and I believe that it can be a much stronger shape, a much stronger structure that's going to be less affected structural integrity-wise by crosswinds, turbulence, storms. The other reason why too is I believe it'll be a lot more maneuverable. In the air, you can maneuver side to side relatively quickly. That's not really something that's possible for a ship to do on the water. Also, given that the craft is disc-shaped, that means it's going to be almost perfectly circular, which means you can make it modular. Each section, each wedge of the circle shape can be an exact replica of all the other wedges. So it's going to be very easy to mass produce at low cost. By having a homogeneous modular design, you're really saving a lot of money on research, structural strength testing, just a whole lot of ways that you're saving money there. With design and iteration and all of that. The other thing is too, back in the 20s and 30s, they kept building larger and larger airships. I want to build a whole bunch of very small ones first and really put them through their paces before I even begin to build one that you could ride in. My idea for the first few test models is something that can really just carry a cell phone around. So you could send a cell phone out somewhere and have a Skype call with somebody and, you know, kind of like a remote presence drone, but one that doesn't have to use energy to stay aloft because it's floating, because it's got hydrogen inside. A lot of people really freak out about hydrogen. They say, oh, it's super dangerous, it's flammable, it's explosive. It is in an oxygen-rich environment, and the atmosphere is an oxygen-rich environment. However, there were literally hundreds of airships that flew perfectly with no issue that used hydrogen until the Hindenburg, which, as we discussed earlier, was covered with thermite, gunpowder, and rocket fuel. So no mystery as to why that had a problem. I think that hydrogen could be completely safe One of the things that I'm planning on doing is having the hydrogen ballonets, that's what you call the balloons that provide lift that are stored inside of an airship, a term invented by Alberto Santos Dumont, who was actually the inventor of the airship, is to have those ballonets in an environment that isn't oxygen rich. One possible option is nitrogen. Nitrogen's in the atmosphere, it's everywhere, and I don't believe that hydrogen and nitrogen react explosively, so that might be a possibility. One of the other advantages of circular modular design is that the entire airship is going to be safe even if part of it fails. So if you've got 8 separate sections and one of them fails and is no longer providing buoyancy for the superstructure, the other 7 still are. Similarly with propulsion. My idea for propulsion isn't to use traditional propellers, but to use something similar to the Dyson air multipliers. I don't know if you've ever seen those fans, the big hollow ones with a circle in the middle. Reason being, they're much more efficient than propellers. Now they might not provide as much thrust, but A, there's going to be 8 of them. B, if they're more efficient, you really only need to have enough thrust to counter the prevailing wind or counter the currents that you're in. The idea is to be able to fly at 100 miles per hour, which means you'd be able to stay put if the wind was going 100 miles an hour, which is a pretty extreme wind. You don't get 100-mile-an-hour winds that often. There's a helicopter. One of those just went down the other day. Everybody died. And also they're very noisy and inefficient. So I'd really like to replace helicopters right away. The other advantage to using the Dyson air multiplier design is that you only need to have one moving part, because you could have one giant impeller at the bottom of the structure operating through ducts to all of the propulsion thrusters. And this way we're saving a lot on weight, which means that we need to have less volume for the ballonets storing hydrogen, which means we can be more efficient, smaller, lighter, faster, cheaper. And that's really what it comes down to, is cost. If you're building something that's very lightweight, you're using less material. If you're using less material, it's generally lower cost. And that's the idea, to make these vehicles cheaper than you can make a car, truck, or a van, maybe even a motorcycle. I have a background in software engineering and information technology, such that I understand that the way computer systems work, networking work, and a lot of the things that are going to be vital for the navigation system in particular are just things that I'm familiar with and know how to program. A big part of the problem that Tesla's having with automated cars is they have to deal with existing antiquated infrastructure. They have to deal with traffic, with roads, other people driving. There's just a lot of rules when you're trying to navigate a car through a city that aren't going to be an issue if you're in the air. In the air, you really just need to avoid other craft in the air and avoid airports and flight paths where, commercial airlines fly. It's a lot less to worry about. So it'll be a simplified set of things that you need to program the algorithm to avoid. I've got a pretty good idea on how to do the 3D modeling of the surroundings. We can have navigation be absolutely safe, more safe than a car, maybe even more safe than walking, statistically. So that's the idea that I have for my own role in the project. But I am going to need several other engineers and employees on this project. For one thing, I'm going to need some aeronautical engineers. There's going to be a lot of things that we're going to have to test. We're going to have to do wind tunnel testing. We're going to have to do computer modeling. We're going to have to do actual flight tests. There's a lot of math involved in some of those aeronautical equations that I'm just not familiar with. So I'm going to need somebody who does that. I'm also going to need a materials engineer, at least one. A lot of the materials that I have in mind are things that exist right now that are very common and abundant, kind of off-the-shelf parts, but some of them are not, and we may have to figure out what's going to best serve our purposes as far as materials, what kind of compounds and elements we're going to be using for those materials, etc. And that's, again, something that's not really a specialty that I have, so I'm going to need a materials engineer. Also, I'm going to need some kind of mechanical engineer. Built a lot of things in the past. I've remodeled a lot of old cars and computers and houses, so I'm pretty good with 3D design on paper. I'm not really an expert when it comes to Blender or any other 3D modeling CAD software. That's just not something that I pursued myself, and we're definitely going to need somebody who's really good at 3D design, especially structural engineering, where the rubber meets the road as far as putting it into a computer and modeling it. It's also very likely that I'm going to need at least one electrical engineer, if not several electrical engineers. Obviously, the entire system is going to be a giant electrical system. I want to have pretty much most of the surface of the airship covered with photovoltaics, and that to be the primary power source. We're also going to need some kind of battery array or ultracapacitor array. I'd really like to use something abundant that's not very costly, so that we can mass produce it and mass cheaply. I don't know where we're at with graphene ultracapacitors specifically. I know they've made a lot of headway on that, at least design wise and in the lab. I haven't seen commercial ones available that I feel are a reasonable price at this point, and I haven't seen them mass produced. And it's telling, for example, that Tesla is not using graphene ultracapacitors. That makes me kind of think that they're not ready for prime time. However, if we could use something like that instead of lithium-ion batteries, I think we'd be a lot better off in the long term. Definitely there's going to be a lot of electrical engineering to do on this whole project. And again, that's something I'm not, I've dabbled in, I've soldered a lot of things together, I've built 3D printers, I've, obviously done everything regarding computers and routers. Actually designing a system from stem to stern and understanding all the electrical requirements is going to require at least another engineer for that. Then of course, if you're managing a giant project like this and trying to compete head to head with companies like Tesla and Ford and Boeing, and that is the intended goal of this project. There's just going to be so many things that are going to need to be done. HR and accountants, all the glue that's going to put a machine like that together. Social media manager, I'm not really that great at this kind of thing. I've got a nice phone and it's a beautiful day here in Waikiki, and I can speak reasonably well with a fairly clear English American accent, but ultimately I think it would be a lot better if we had a higher production, something that really kind of grabs the attention of the people, better 3D modeling, better conceptual art, all of those kind of things. I'm going to need all of that. I think it's time to liberate humanity from the two dimensions that we've been living in for our entire evolution. It's time to get into the 3D. And I don't see that happening with airplanes or helicopters or jetpacks. I don't see that happening any other way than very calmly floating away with a computer-controlled airship. We've kind of been on this path for the last 80 years since the Hindenburg disaster that is kind of like a weird dystopia where we avoided maybe a future that could have had a lot more flying involved. And I think it's time to get back on that track for our species and kind of liberate people from government, liberate people from location, liberate people from the ridiculous price of housing. And all of this can be served by autonomous solar-powered airship. I think that I've got a plan and a vision that could actually work. Why not try? I think that it would be so much better for our species to be freed from the bonds of gravity and from the bonds of the system that we're in, that it's worth a shot. People are talking about universal basic income, the migrant crisis, and all these issues. And the reality is none of these issues are going to solve themselves. We have to solve them. Waiting for the governments to solve them, a catastrophe. It's never going to work. It's never going to happen. And the current situation that we have with the corporate control of almost everything that we live and use every day, whether it's like the crazy monopoly that Amazon has become, or the crazy monopoly that Google has become, unless we really build a decentralized infrastructure for ourselves and our families to escape into, we're going to be underneath the corporate and government jackboot forever. And I want out. And I want out for my kids. I don't want my kids to have to rely on Amazon and Google. I want my kids to be able to float away and go wherever they want and get the cheapest mangoes on the planet for free in an autonomous solar-powered airship. And I know that sounds crazy because we're not there right now, but it's certainly possible. I mean, they had floating hotels in the 30s that could fly across the whole Pacific Ocean. You mean to tell me that nearly 100 years later, we can't have that for a lower cost, decentralized, where everybody owns their own, that's, computer autonomously controlled? I think it's possible. But we live in a world doing these kind of things isn't possible without a little bit of money. And I'm gonna need money. I'm gonna need some money to hire some of these other engineers. I'm gonna need money to find a location to build these things. I'm gonna need money to do wind tunnel testing and software modeling, and I mean, all of this is gonna cost money. There's no such thing as a free lunch, and none of this is gonna be free. I do think I could do it with a shoestring budget, relatively inexpensively. I could probably do 90% of it myself, although that would take a long time. I think that if I was able to get some of these other engineers on a team in a location together, working proactively as a team on each individual problem as they arise, we could go a lot faster. And that's what I'm looking to do. I hope you're with me.